Okay, so let's get started with Unit 2. And in Unit 2, we're going to talk about statistics and inference, which is making decisions based on data and, tangible trends that you can actually see. So today we're really going to just go over a lot of definitions, a lot of language. It's important for you to understand what all these different words mean. There won't be any homework over this particular section, but it's really important for you to listen, take some notes, definitely understand the differences between some of the words that I'm going to emphasize. Before we get started, though, I have a silly phrase for you today. Okay. This is your attendance quiz silly phrase. There's some people that are a little bit confused, so I'm going to be a little bit more intentional. Today's phrase is I danced with a toaster and it won. Yes, I danced with a toaster and it won. Okay, let's get started then. All right, so let's talk about some statistic definitions. First off, population. Population is the population of a study group is the group that you collect data on. And why is it important? Well, as the population changes, the data skews and maybe opinions and data polls or something like that. So it's really important that you're very specific about the population. So a lot of times in the news and such, you'll hear that a certain poll is a certain percent, but you must always ask yourself who was polled in that because it is about what the population was. So you have to be clear about your population when you're trying to describe data, and that's what we're going to do in this unit. I forgot what I was doing here. I'm not on a PowerPoint. I'm on something different. All right, so let's look at this first example here. A newspaper website contains a poll asking people their opinion on a recent news article. So what's the population? So is the population everyone in the world? Oh, no. Not every, I mean, I guess with the internet, anyone in the world could be reading a newspaper website. Is it in a specific region? Just say that this is the Atlanta Journal-Constitution. Is it just everyone in Georgia? No, no. Is it just everyone in Atlanta even? No. It is the people that subscribe to that website. So the population are the subscribers of that site. All right. Then there's this word parameter. And a parameter is a value. It's something that's been actually calculated using the data from a population. So parameters is kind of like a generalized term that they use to describe many values. For example, we might be talking about the average of a class score. That would be a parameter, or maybe the average height of third graders. That could be a parameter. Also, another important statistical term for you to just be aware of is census. And census is a survey of an entire population, okay? And there's very few, like only in the US are there two true censuses, whether they all get fully participated in or not. There is the 10-year national census, that's actually kind of been in the news lately, but there's a 10-year national census that goes along with redistricting congressional seats and such. And then voting. Voting is also something that is open in a limited way to the population. I'm going to retract me even saying voting. I don't even know why I thought about that, but I am definitely going to say the census is something that is that surveys the entire population, but generally surveys don't ask every single human being in a particular population. We usually do things called sampling. Okay, so a sample is a smaller subset of an entire population, and almost all statistics are done on a sample, and then the outcome that we get, the conclusions that we get from a sample, then we can extrapolate or we can kind of project onto the entire population. So it's really impossible to get all the say I don't know, eye color data from every single person in Georgia, right? That would be really, really hard to get, but we could get a sample. We could take samples and then we could make educated guesses using statistical analysis and stuff on deciding what that general population is. Now, a statistic is a value that has actually been calculated from the data. That is, you have found an average, you have found a standard deviation, you have found the the range of the values. That is considered to be a statistic. Anything that you calculate on the data is called a statistic. And sometimes that's confusing because it could be many different things. Statistic is kind of like a broad term, like Kleenex is for facial tissues, like Kleenex is really, really specific. And when we think about statistics, we think about it as something specific. But in the term here, statistic, it's more of a broad general term that we can use to describe anything that we calculate using data as our base. Okay, so let's take a look at another example or two here. This example says to determine the average length of trout in a lake, researchers catch 20 fish and measure them. What's the sample here? And what's the population that's being studied? Okay. So, and here's the cool thing about statistics, honestly, there's really no hard, fast, right or wrong answers. A lot of times you can defend whatever you think your answer should be because that's just the way that you were thinking about it. Do note that these questions that I have here in this lecture that are just meant to kind of highlight the differences in these definitions and these statistical terms are not really great questions here. Like I didn't write out a 2-page narrative to describe what my study might be or something. Okay, these are just general. You're always going to find some pitfalls in anything that I throw together here. Okay, so getting back to this question, we're catching 20 fish. We're going for trout in a lake. What's the sample? Well, the sample is the 20 fish caught. And the population, well, that's where we caught the fish some. So that would be all fish in the lake. So that means at some point they were throwing back fish if if they weren't getting trout or whatever. Okay, next example, a college reports, bleh, sorry y'all, it's been a hard day. Let me just take a moment. Okay. A college reports that the average age of their students is 28 years old. Is this a statistic or a parameter? Well, I want you to always think that anything that has had data, has had calculations done, and we know how do we get averages? We add them all up and then we divide by the number of people, right? So say we were averaging the ages in our particular class right now, we would add up everyone's age and then we would divide by the number of people in our class, and that would give us the average age. So that means we've done math, right? We've calculated, we've collected data, we've asked everyone how old they are, and we added it all up and we divided it. We calculated something out of it. So this would be a statistic. Okay, let's keep on going here. Now, this is a big one, okay? Qualitative versus quantitative data, okay? So qualitative data is data that are pieces of information that allow us to classify objects like eye color or skin tone or um, uh, birth sign, right? Like your horoscope sign. These are qualitative things. These are not tangible numbers we could actually calculate. Favorite movie, the favorite color pen. These are qualitative data things, and I wrote a few more here, like age ranges and class memberships in college and gender, all those things. Those are qualitative data. And then quantitative data are responses that are numerical in nature, like weight, height, length, um, time spent, grade, numerical grade, as I say, number of times an event occurred, the quantity of the times people said that Forrest Gump was their favorite movie. You know, there's a lot of things there. So quantitative data is measured in number. Qualitative data is basically measured in words. Okay, you're going to get words generally out of that. Okay, so let's see what you think here. Exercise 4 says we might conduct a survey that to determine the name of the favorite movie that each person in math class saw in a movie theater. Would this be quantitative or qualitative? So take a minute. You guess. This would be qualitative data, right? You're not going to respond with a numerical value. You're going to respond with a word, and the chances are that out of 30 of us that we're not going to have a lot of repeats. There'll be some, but there won't be that many. So this would be qualitative. Okay, and then example 5, let's have you do, well, let's not because duh, right? One's going to be one and one's going to be the other, but let's read it. A survey could ask the number of movies you've seen in the theater in the last 12 months. 0, 1, 2. Personally, I've seen 0. Well, I did go see that what is that movie with Michael Keaton, the Halloween movie. I went and saw that. uh Beetlejuice. I went and saw Beetlejuice 2 in the theaters, but I think that's been more than a year. So I think I'd fall under 0. But anyhow, would this be quantitative or qualitative? And in this case, this is quantitative because we want to know how many times did that happen. Awesome. All right. So one thing that is a big idea in statistics is sampling. Okay. Like I said, it's almost impossible for you to survey, say, an entire group or collect data on an entire population, like every human on Earth. Not possible. I don't think we could possibly do it. I'm not even sure that we could get every human in Georgia or even every human in Southeast Georgia area, right? So pretty difficult to do the entire population. So we have to depend on samples so we can make statistical decisions. All right. So for a study to be legitimate, you have to have some kind of sampling methodology. You can't just willy-nilly do it. So to make something scientific, it has to be based in something that was done in some sort of logical way that could be replicated. That is like the biggest thing in science. The most important thing in science is for science to be believable and for science to be science. It has to be able to be replicated over and over and over again where people get the exact same outcomes. Okay. So there's sampling that happens, and we're going to go over a few of the sampling things. A simple random sample in which, maybe you just choose some people. Put everyone's name in a hat where it would be equal and fair that everyone got a shot at it. That would be just a very simple random sample. But it gets very, very complicated, and I don't want to get too far into it, but let's look at some of the other kind of sampling. There's stratified sampling, and that's where a population is divided into several subgroups, also known as a strata, kind of like rocks, different kinds of rocks in a rock bed or whatever. Okay, so random samples are taken from each of those subgroups with sample sizes proportional to the size of the subgroup of the population. Now, I would say that this is probably very, very often done, to be quite honest with you. I know that this is very often done. Just look at any social issue, to be quite honest, but we could be talking about grouping into age groups. We could be talking about grouping into gender. We could be talking about grouping into race, all sorts of things here in stratified sampling. Okay, quota sampling. It is a verified a stratified sampling, whereas in the samples are collected from the subgroups until a desired quota has been met. Okay, so that would be quota sampling. We have to have X number of freshmen, we have to have X number of sophomore, we have to have X number of junior and X number of seniors in this poll that we're taking for our college campus or something like that. Cluster sampling is where the population is divided into clustered groups or subgroups, and a set of the subgroups are selected. So that is, it might sound like that is very similar to stratified, but I guarantee you that there is a lot of wiggle room in cluster sampling. There is systematic sampling. Now, this happens a whole lot, and I think that this is kind of fair. That's when like every fifth person that comes through the door at the store gets a free ice cream cone or something. That would be a systematic sampling. Or if you're ever online and you get chosen for a survey, maybe you click on like a online shop or something, and you're like, you've been to this place before, but this time you're chosen for a survey. You might have been like the 300th person that clicked on it that day, and that's how you were chosen for the sample. So that would be an example of systematic sampling. Convenient sampling, that would be if we were all in a classroom, if I decided to just sample everybody that was right in front of me, that would be convenience sampling, kind of difficult to replicate, but certainly still a fair sampling methodology. And then voluntary response sampling, where we do this every semester. We send out your course evaluations for your instructors at the end of the semester. It's done by a company called IOTA, and they come to you through email. I don't get to see them. None of our instructors get to see them, and you get to answer questions. That is a voluntary response sampling. In other words, we can't count the people that don't respond to that. Therefore, we're only taking samples of those that do respond. Okay, let's see if we can't put these ideas together. I don't know why that came falling up, but it sure did. Let's see if we can't put some of these ideas together. So let's determine the type of sampling method that was involved here. On A, every fourth person in the class was elected. Well, that is without a doubt that systematic sampling. Now, I don't want you to sleep on this and all of these definitions that come in this statistics section, because in the exam you will have some matching definitions. So do be sure that, you write these down, you make sure you understand them and stuff like that. Okay, another one. A sample is selected to contain 25 men and 35 women. Now, I tell you, there's a couple of samplings that would fit here, but because they're calling specific number, I need a specific number of this group of people and a specific number of that group of people, then this is very clear to me to be quota sampling. The viewers of a new show are asked to vote on the show's website. Well, seems like convenience. Right, if they're there on the website promoting this show that clearly they like. So I'm going to call it convenience sampling, but you might think it was something else. I wish we were all in the classroom together because I like to talk about this. Like I like to have that discussion on what do you think it is? What do you think? But unfortunately, it's just me talking to you. So. I always misspell convenience, so hopefully I did it right, but I don't even trust my notes because that's how often I misspell convenience. Okay, a website randomly selects 50 of their customers to send a satisfaction survey to. Voluntary response. My writing's getting a little terrible. Let me get back up here. Now, what goes along with statistics, hand in hand, maybe even more important than the statistics themselves, are biases that are found. Okay. When you're surveying people for opinions, when you're collecting data and doing things like that, there are biases that are built into every single one of us. No matter how unbiased you think you are, there are always going to be underlying biases that you don't really realize that you have from growing up, from your raising, from your community, from all sorts of different ways, all sorts of different places. Okay, so I'm just going to run through some of the biases real quick, not getting too deep. Remember, this is a unit in a class about statistics, so I'm just knocking them out here. So let's look at the sample. First, there's sampling bias when the sample's not representative of the population, right? So, if they want to know something about X, but they're really only talking to people that present Y. Okay, that would be a sampling bias. Voluntary response bias, and that's the sampling bias that often occurs when the sample is volunteer. They're eager to say their opinion, they're eager to participate, they're eager because of one thing or another. Maybe they are against drunk drivers because someone died and this is a survey about drunk drivers, or there you never know what the biases could be underlying. Also, there's a self-interest study where the bias occurs when the researcher has an interest in the outcomes. So, say someone is out peddling a new drug or something, and they put out a study and they're talking to a group of doctors or whatever. Well, there's going to be a self-interest bias in the studies that they present and their conclusions and stuff because they have interest in that outcome. Response bias, that's when a responder just gives an inaccurate response for any reason, like, excuse me, I have certainly put total jerk responses on maybe somebody's serious survey because I didn't want to do it then, and that then becomes somebody's piece of data that they have to handle, and that would be response bias, that I was just an ass, basically. Perceived lack of anonymity, when the responder fears that giving an honest answer might negatively affect them. Say you're filling out a survey, you work for a big Fortune 500 company or something, and you're filling out a survey about, your happiness and welfare at work, and you're afraid to say, my immediate supervisor micromanages me and my days are full of microaggressions. You don't want to say something like that because you're scared that you don't really have that anonymity, and you're going to say everything is great because I don't want any retribution for my opinion. Right? So that would be a perceived lack of anonymity. There's also the loaded questions where the question itself might like guilt you into maybe not the answer you specifically would choose, like, well, everybody else is voting this way, you should vote this way, or something like that. And then there's the non-responsive bias, just straight up people just refusing to participate, and that can also affect the validity of your outcome. So when you do like a serious study, bias is part of your conclusions. You have to investigate every possible bias to explain what you've got, what your answers and what your conclusions are. You have to argue it from your side and from every other side around. So it's always important to keep your eye out for bias. Okay, so let's answer this. I got a few questions, see if we can figure out what bias it is. First one. A survey asks how many sexual partners a person has had in the last year. Well, first, I hope it is uh, you know, blind study, but I'm going to say that that is definitely a lack of anonymity. All right, a radio station asks listeners to phone in their choice on a daily poll. What kind of bias would that be? Yeah, you're right. Volunteer. VOLUN, voluntary bias. A substitute teacher wants to know how students in the class did on their last test, and the teacher asked the 10 students sitting in the front row to say their test scores out loud. What an asshole. Uh, Now, there's a whole bunch of different things we could say here, right? I'm going to throw a couple of them. First off, I think it's sampling bias. Just grabbing what's in front of you without actually even thinking about it. Um, Also, because it's just the front row. Um, so let me just stick with that. Good enough. Again, you're not really going to be required to do much more than be able to define a couple of these biases. Here's another one. The high school students are asked if they've consumed alcohol in the last two months. Well, that's definitely a lack of anonymity. The Beef Council releases a study stating that consuming red meat poses little cardiovascular health. That's self-interest. And finally, a poll. Do you support the new transportation tax, or would you prefer to see our public system just simply fall apart? That's a loaded question. See that guilt? Trying to throw that guilt in there. All right. Okay, now there's two main kinds of studies. There's an observational study. That's a study that's based on observations and measurements. That's when, those researchers are sitting in the field with their little notepads and they're watching the wild animal pride over there do their thing and they're taking notes or they're talking really, really quiet. That would be something. It could also be, say you're like my example here, if you're sitting at an intersection counting the number of people that fully stop versus not fully stop or something like that. Those would be observational studies, and that's not what we're going to focus on actually. An experimental study is one that effects of a treatment are measured. So basically, it's where maybe you're just going along and then we do an intervention like impose a diet, an exercise regimen, better sleep, some skincare. We do something and then we measure those outcomes afterwards and compare, say, like the before and after. Okay, so the difference between an observational study and an experiment is an observational study does not impose anything to change the outcome, but an experiment, we try to do something maybe to change the outcome or something like that to see how the outcome would be changed with some treatment. So let's find out if these are observational or experimental studies. So the first one is the weights of 30 randomly selected people are measured. Is that observational or is that experimental? Did we apply something to those 30 people or did we just simply measure their weight? So that would be observational. Okay. Subjects are asked to do 20 jumping jacks and then their heart rate is measured. Now, this is an experimental study because we applied a treatment and then we saw how it changed. Okay. So this is experimental. Twenty coffee drinkers and 20 tea drinkers are given a concentration test. This one's kind of one of those that I didn't quite give enough information. I'm going to call it experimental, and I'm going to say what's not been written here, which is they took a concentration test. They drank their tea and their coffee. So I'm going to call this experimental. But could very much be argued that it's observational. Just saying. Okay, a pharmaceutical company tests a new medicine for treating Alzheimer's disease by administering the drug to 50 elderly patients with recent diagnosis. Well, this is experimental because they've administered the drug to 50 of the elderly patients with recent diagnosis, but leaves other patients for them to compare. They just selected 20 of them. The wording's not the greatest. Got to read a little bit between the lines. Experimental. A gym tests out new weight loss program by enlisting 30 volunteers to try the new program. Well, because it's some new weight loss program, we're going to assume that they just didn't pick 30 people to just watch for a while. I'm going to call that experimental. Again, I would cave on any pushback that was within reason here. You test new kitchen cleaner by buying a bottle and cleaning your kitchen. Again, I'm going to call that experimental because we're in our own kitchen and we've been cleaning with the old stuff and now we clean with the new stuff. So we're going to see before, treatment, after. So I'm going to call that experimental. And finally, the weights of 30 randomly selected people's backpacks are measured. But we didn't do anything with them. We just measured them. Observational. Still important, especially if you have back pain from carrying around a bunch of books, but still observational. Okay, and then I just have a few more little definitions for you, just so you're aware of them. Confounding is one. Confounding occurs when two potential variables that could have caused the outcome, like there's two different variables that could have caused it, and it's not possible to determine which caused the result, so that you would have a confounding situation. And you could think of that as maybe in testing new drugs or something, and the patient had multiple morbidities, and you weren't really sure which one caused something, or you couldn't say, oh well, they did worse on this drug specifically because of this drug, because they actually have this other thing and this other thing. So you couldn't really point the finger. That would be confounding, when you could not actually point the finger on what the issue was. Most studies make comparisons, almost all do, not everyone, but almost all do. And this is usually done with a control group and a treatment group and or comparison group, sometimes called the treatment group. I'll write that. The placebo effect, surely you're all old enough to have heard placebo effect before, but that's when the effectiveness of the treatment is influenced by the perception of how people think the treatment is going to do for them. A placebo is a dummy treatment that's given to control a placebo event. So in the case of, say, a study where they're giving a new kind of cancer treatment, right? And they've got a group of 100 patients, and half of the patients are going to get this little pill, and the other half of the patients are not going to get this little pill. A lot of times it's important for everyone to think that they're getting the little pill and or getting some kind of treatment. So they're psychologically, there's a lot to do here. So they would give the group that's getting the new drug, the actual drug, and they would give the other group the placebo. So it would look like the drug. It would it would come across in the same packaging, the same way that they received it. Was it a pill? Was it a liquid? Was it an infusion? Was it a shot? Whatever it was, it would go the same way, and that would be considered the placebo. And then finally, in most medical studies, at least the minimum in most medical studies, it's done where it's a blind study where the participant doesn't know if they're actually getting the real drug or the placebo in this case. And then in the more rigorous studies that stomp out the most bias that they can would be a double blind study. And that's where not only the participants don't know who's getting the treatment and who's getting the placebo, but even the people that are conducting the study, that are running the study, they don't know who is getting the placebo and who is getting the drug. And that is done in a double blind study where there is one person that is not generally involved, but an overseer of the entire study that actually knows who is who, but everyone else, all of their records are just what we would consider blind. You wouldn't know at all who is who. Okay, well, that was just a whole lot of talk. Again, there's no homework for 2.1. When you go to do your homework, you'll see that the homework for lecture D is actually 2.2 homework. So there'll be 2 lectures this week, but only 1 homework because this lecture doesn't really have homework. Okay? All right. As usual, if you have any questions, please don't hesitate to reach out to me. Those of you that have know that I am responsive to you and I have solved your issues. So please don't hesitate to reach out to me and you'll have a very good day.